be there in person. I'm just going to switch and share my screen. So, and hopefully everyone can see this okay? Today I will be talking about artificial intelligence and real-time communications. Before I do that, let me just briefly introduce myself. I think as anyone said, my name is Hart. I'm an analyst and consultant. I specialize in real-time communications products. Many of you probably know me from WebRTCHacks, which is a blog for WebRTC developers. In addition, on the topic of AI and RTC, I've started a new blog just to look at that content, and you can find that at cogent.ai. I still continue to do WebRTCHacks, and WebRTCHacks will be about WebRTC, but for other topics that aren't necessarily just about WebRTC, covering those in Cogent AI. In addition, I'm also involved in the Cranky Geek event series. We hold an event every year. This November 16th, we're having a show that's dedicated to AI and RTC. If you're going to be in San Francisco, that's great. Please come and attend. But if not, you can also check out the videos on YouTube afterwards. And lastly, one more plug, I also recently did a long market research study with Saeed Levent-Levy, which many of you might know in the WebRTC community from Lockheed Inc. So we decided that we wanted to do and take a deeper look at the intersection of artificial intelligence and machine learning with real-time communications. So to understand this better, Saeed and I teamed up and we wrote a 147-page research report on this subject where we talked to more than 100 vendors and then had an industry survey and had deep conversations with more than 40 vendors. So a lot of what I'm going to talk about here is supported by the research I've done. In addition, I also came off a long-term project at a telco Vodafone where I ran a new product incubator, and we launched a speech analytics service among many other types of services also. So maybe before I start, let's just talk about some definitions and what is AI and RTC. I'm not talking about science fiction robots making phone calls here. I am going to reference applications of machine learning and how machine learning techniques, especially deep learning techniques, can be used to improve and expand real-time communications. I'm going to mostly focus on use cases and applications and not the details of how to build a deep neural network. I found actually there's a lot you can do without being without having your PhD in computer science and machine learning to implement a lot of these algorithms and make artificial intelligence and machine learning techniques useful for your real-time communications applications. During the study, we found 4 major applications that we used. The first, and I'll go through each one of these, right? But the 4 main areas where we break up the report, and then I'll break up this presentation, is in speech analytics, voice bots, computer vision, and RTC optimization, using machine learning to optimize lower-level real-time communications protocols and networks. So I'll start with speech analytics, and this is by far the most common and the one that's been being used the most today across a variety of applications, but especially within traditional telephony environments and call centers. And this can include things like monitoring call center agents, doing transcription during a phone call, or even doing translation during a phone call or a presentation, which might be nice for you all right now. So speech transcription has improved quite a bit over the years. Speech transcription, I'll use other terms such as automatic speech recognition, ASR, or speech to text, STT. Might be other terms you hear for this. Thanks to deep learning, the word error rates, at least the word error rates claimed by the intervendors, and this one is from Google. Microsoft has a similar paper showing other numbers. They all say that they're at or near human levels of accuracy, and this has improved quite a bit in just a short period of time. The reality is, though, I found a lot of the transcription still has many different challenges. And as an example here, this is actually a real transcript that I used recently on a phone call where I was introducing myself. And this was on another system that was designed for helping to take notes during conference calls. And you can see here, the machine transcription did not do such a good job. There's a few things to keep in mind here. One is specifying the language. In this case, the system defaulted to using U.S. English, which for me is fortunate. That's the language I speak best, and that's my accent. But usually the system does not default or does not know what language you speak. Right? You need to tell the system before it does the transcription what language it's dealing with. There's not great technology yet for automatically identifying languages. And my transcription here is probably worse than average, but I would say it's not uncommon. And back on the language, I'm sure you deal with this a lot, especially with Korean and having Korean support with some of the major speech-to-text vendors outside of Korea. I'm lucky I speak English, and my particular accent, American English, is by far the most supported language. Many vendors also support different dialects of English, such as British and Australian and Indian accents. Right? I suspect that there's probably not a whole lot of support. If you see language support by some of the major vendors, it's probably just Korean and not specific dialect or a regional dialect there. But fortunately, a lot of this is improving. The newer algorithms require a lot less training data, so this means it makes it much easier to go and build support for new languages, much easier than it used to be in the past. In addition, once you have the language correct, there are a number of tools to improve issues like, as you can see here, like WebRTC. That's not in a dictionary. That's never going to get picked up properly. But most speech transcription engines, if you program them correctly, have the ability to build a custom dictionary. And that custom dictionary can be used to say, all right, phonetically, WebRTC sounds the same as WebRTC. I would prefer that to be WebRTC, so it will override the default phonetic and apply what the user would like in the custom dictionary. Right. I've also seen these systems are getting much better at handling with some of the speech disfluencies, where you start talking and perhaps don't have a nice continuous sentence, or you change your mind in the middle of talking, and they're getting much better at adding punctuation and handling this. But another very important note is that sometimes a perfect transcription is not always needed. So higher level speech analytics systems actually look for patterns throughout the course of the entire call, not just looking at specific words. Right? And these patterns are matched to business outcomes. So if you notice a call, for example, one agent or one particular script always results, or one communication always results in customer purchasing or a good customer satisfaction score, these systems can look for that. And those patterns don't necessarily, they're loosely related to the actual speech and the text, but they, a lot of times, there's more important factors in the call, such as how often the agent speaks versus how often the customer speaks. No one likes it when the customer service is talking over them or doesn't give them a chance to speak. Right? And oftentimes there's other metrics, even like speech rate, or did the agent spend enough time during the introduction to introduce themselves or walk through the problem. Right? We're seeing a lot more work going into and tools to not only look at speech content, but also look at other paralinguistic content and look at caller emotion and sentiment. And this emotion and sentiment doesn't always need to be tied directly to the words. So advanced systems out there, one company that comes to mind is Cogito. They have a system that actually doesn't do any speech-to-text transcription at all. They just monitor the waveform of the speech, and they can predict the outcome just based on the waveform and analyzing emotion and sentiment from the waveform. So I expect we'll see a lot more from speech analytics that goes beyond just getting the text out of the call. Another area that we looked at, I think that is really exciting, is voice bots. So when I say voice bots, I'm referring to technology like smart speakers and AI assistants. Smart speakers like the Google Home, which is Google or Siri, that are there. And there's a number of other systems that are open source or proprietary or specific to one vendor out there that can be used for different use cases. So building a voice bot in a lot of ways, it's very complex. You not only need to incorporate a lot of the technologies from speech analytics, such as transcription and natural language understanding, but you also need to generate realistic speech in most cases, and you need to deal with the real-time interactivity of the customer. But we saw very broad interest in use of voice bots in building out voice user interfaces. Most telephony devices, like IP phones and especially conference phones and video conferencing equipment, they're very interested in adding voice user interfaces to these devices. And it's a very natural fit in most cases because people are already talking to these devices. They're comfortable speaking out loud to them because that's what they need to do for a call. And most conference room equipment it already has the hardware set up to be able to capture good audio with minimum noise from a variety of locations throughout the room, so it can give a good speech transcription. So most of those devices have a multiple microphone array that does additional processing to help make audio good. And so it's a very natural fit to turn a conference phone. The thing about that gradually evolving into a kind of smart speaker to enable conferences. Right? So we found a lot of companies are at the very early stages of looking at this. There's relatively few who I'd say have very comprehensive strategies or building stuff, but we're starting to see more of that. And one area in particular that we'll see first is in interactive voice response IVR systems. Traditional IVR systems were designed for ETMF, touch tone input, and they're usually set up with multiple levels of menus. And because people can't remember more than a few menu options at a time, you end up having, you can't put too many menu options, so you end up having these very deep, multi-level menus. And users really hate that. It's really frustrating to go through and have to, hit an option and wait a minute and hear all, the next set of options and then hit another button. It just takes forever, and everyone hates it, right? Navigating, what these voice bots do is allow you to navigate the IVR system using natural language without the need for that complex menu. So the user can just say what they want and use natural language to get the information they need. And this is obviously good for users because it's much more comfortable for them. Obviously it needs to work. But if it works it's great. Many users are now coming to expect this type of interaction as they use smart speakers in their home and on their mobile phones a lot more. And at the end of the day, this ends up being very good for call centers too, because the longer the user stays on the IVR, the less likely they are to want to drop out and talk to an operator, which is their largest expense. And the reason why they had the IVR in the first place, it was really to offload the operators. What's interesting here, a lot of these systems have been around from companies like Nuance and Aspect and Genesis and many others for a while, but they tended to be pretty expensive, very difficult, time-consuming to program. What's changing now is the introduction of all consumer voice bots, right? And the consumer technology is gradually evolving and penetrating the business market, right? So, a couple examples, IBM, Watson, and they've always been business focused, but just in the last year and a half or so, they've built out a voice gateway option to make it easy for call centers to plug their existing infrastructure into Watson, IBM's Watson AI for handling call center calls. Amazon, similarly, you might have heard of Amazon Connect. Amazon's natural language engine is called Lex. They now have a number of options to make it easier to integrate Lex into an Amazon Connect call center call. And this is all available pretty much for anyone to use off of Amazon Web Services. Microsoft similarly has a language processing platform that's called LUIS, it's Language Understanding and Intelligence Service, and it has an additional bot builder framework. And they've done work relatively recently to integrate these into Skype and Skype for Business for work environments. And also, very significantly, just this past summer, Google launched its Contact Center AI initiative, where it's partnered with about a dozen major communications providers and vendors. And as part of the solution, Google is looking to penetrate call centers by using Dialogflow, which is their natural language understanding engine, and some other tools they're using to do document analysis and speech analysis to help agents respond to and answer questions more quickly, right, during calls. So, and this is a brand new initiative, right? So you can see in a relatively short period of time, a lot of these vendors have gone from consumer-oriented applications and use cases to now trying to go after not just small business, but very large contact centers. And ultimately, the existing IVR technology that incorporates a lot of this natural language, as I mentioned earlier, tends to be very expensive. And in a lot of cases, it's based on older technology or it uses older machine learning techniques. Not that these vendors aren't capable of doing the newer ones, but they are somewhat stuck in their existing product deployment cycles. Meanwhile, big vendors like Amazon and Google and Microsoft are quickly adapting the technologies they've built for these massive consumer markets, serving hundreds of millions of people, and they're applying that to business use cases. And in most cases, it is a significantly lower cost, and at least often with better performance. And one reason they can have better performance is because they're serving this much larger market with a lot of the same technology with every day with people at home via their mobile phone and their smart speakers. And just as an example, and this was a Google customer at their Google I/O event, but Marks and Spencer is a big retailer. They commented using this voice bot technology, they were able to save the equivalent of 100 full-time employees across a fairly sizable call center. But instead of having store employees handling routing requests basically or answering basic questions, they were able to have this voice bot IVR take on that functionality, and that really saved them a lot of time and prevented a lot of those calls from being routed to employees who would otherwise be doing something else on the shop floor. last area I'd like to discuss, and actually not the last, but the next area I'd like to discuss is computer vision. This domain actually has had a lot of usage in a lot of consumer applications already. With there's plenty of applications out there that put silly mustaches and hats on people. But in addition to some of the social and consumer use cases, there are a lot of business-oriented applications in use cases such as counting people, or identifying or authenticating via faces, or even doing gesture controls and augmented reality. And it's actually relatively easy to use open source libraries and existing work that's out there to build some of this stuff. And you can do this without having a PhD in computer vision. And I proved this by doing some of this myself. And you can see the details on this WebRTCHacks post here. In this case, I set up a TensorFlow server, and I sent the WebRTC stream to it to do real-time processing. And I'll just show this quickly so you have the idea. I'm doing just object detection here. Hopefully this comes through okay on your end. You can see I'm just initiating a web browser, and it picks me up as a person, and it shows the basically the probability here. And this is looking at a desk, picks up a cup, a bottle. It'll pick up the keyboard soon. Gets me a little bit in the background as a person. And I'm not actually doing anything special to this machine learning library here. This is just the standard TensorFlow object detection API that's available that you can get right off of the TensorFlow website out there. And this is available. I built this into a Docker container. But essentially, it's a very simple application at the end of the day. From the browser, I establish the stream, and then periodically send individual frames, and I post those frames to a web server. Those frames get processed by the object detection API framework, and which sends down the object details, like the what it detects, what it is, and the coordinates. And then I just mark that up in a local JavaScript canvas, right? And again, it's relatively simple to do with off-the-shelf tools. But as you saw in the video there, it's definitely not completely real time. There's limitations, and I could probably improve this a little bit if using WebSockets, and I can get a higher power GPU server on the server side to process a lot of that, or maybe even something even more advanced, such as you might have heard of Google's TPUs, their TensorFlow processing units, which are specifically designed for handling and doing hardware acceleration of heavy machine learning graphs. All that would have helped, but ultimately, wouldn't it be nice to do a lot of this heavy processing locally with local hardware acceleration, just like you can do local hardware acceleration with codecs like H.264. And in fact, this is possible, and it is possible today. Intel has a chip called the Intel Movidius chip that does this. And maybe I'll just turn off my screen share in a second, just to show some of this. Google's actually taken this chip, and they built this into what they call their AIY vision kit. And this is just a hat, and actually it goes on top of a Raspberry Pi Zero, which is a very low power single core device with only 512 megabytes of memory, right? So it's able to do complex computer vision processing because of the specialized Intel Movidius chip. So using a lot of the same kind of techniques and methodology, I built the system just as a proof of concept here to show how you can do real-time machine learning with the Google's AIY vision kit in this Intel Movidius, all running on a Raspberry Pi Zero. And I'll show that here. All right, see here it's detecting a cat, and you notice here this is a lot faster, right? This is running. This runs. I can change change the frame rate, but this runs around 15 frames per second, pretty well. Now I should say, I'm just using the standard graph some of the standard graphs that were available, along with the Vision Kit here. But it is possible to train, obviously, and do your own. I have some additional work where you show that. But this works actually very, very well. I should also comment that the whole kit itself, including the Raspberry Pi, Google sells for $90 in the US. I don't think it's available internationally, but I'm sure you can find one on eBay. And originally, when Google released this, just the little hat board here that has the mobility chip, that sold for $45, just to give you an idea of the price range of what these are. Right, and it's not just Intel. The Qualcomm is coming out with these things too. Also, Google's not the only one with a Vision Kit. Amazon also has a product called Deep Lens. This one runs on more of a Intel mini PC. It's more like one of their NUC devices. It's a little more expensive too. It's $250, but there are additional options. I believe you can order that from anywhere in the world. So, another exciting, action is a lot of these computer vision use cases are getting relatively easy to do with some of the native mobile libraries as well. Right. So here's an example from Gustavo Garcia. He wrote a guest post for WebRTCHacks. He works for a company called House Party, and he basically did some demonstrations looking at Google's ML Kit to show how it's relatively easy to do smile detection, and then you can use that smile detection to add additional effects. So in this case, he just was looking for smiles, and if there's a smile, they would rain down hearts, that sort of thing. The same sort of thing is possible. It's not just Apple, not just Google with ML Kit, and this actually was done on an iOS device, but the same thing could be done with Apple's Core ML too. Right, and there are similar libraries, that do detect facial batteries and use that sort of thing, like hats and beards, and make virtual avatars, and so NASA people. I'm sure you've seen some of this. And even in a business context, a lot of this can be used to, maybe you don't want to put a mustache on your business partner when you're having a remote call, but oftentimes it would be nice for someone who's remote to be able to blur out their background. Say that they have a messy environment or at home or just calling in, or perhaps even on mobile. It would be nice to blur out their background to help make that call go better and just have their environment be less distracting and have more of the focus be on the actual speaker. Right, and as you can see here, this is all part of that same post. They did a bunch of analysis to see how the frame rate impact the CPU usage. Very similar to something outside that you can see. The higher the frame rate, obviously, the more CPU consumption this takes. I should mention here this is all being done on standard Intel or standard iOS, Apple iPhone hardware. Certainly over time, as hardware acceleration and special hardware gets involved, the CPU usage will go down quite a bit, and that will allow for more real-time frame rates. But for applications like what was shown here, in most cases you don't really need to process the image at 30 frames per second. In a lot of cases, doing at 1 or 2 frames per second is more than sufficient. It's also was interesting to note that you might think all this machine learning stuff would take a lot of space, but actually the ML kit code is very small actually in relation to the WebRTC application itself. Right? So a lot of this can be done without consuming too much resources if you engineer it properly. And there's a lot of good, great guidelines within that post, so I recommend you check that out. It's also exciting to see that a lot more WebRTC and computer vision will be coming to the browser. So as part of the standards process, the W3C and what they're looking at for WebRTC next version, they're actually specifically looking at a lot of these use cases that I mentioned here, and trying to figure out ways to improve the WebRTC processing pipeline and open that up so that real-time machine learning can be applied to those streams within the browser, right? So again, this is very early days. They're just identifying this as a use case, but I think it's pretty exciting that this is one of the some of the applications that are looking at that hopefully will be coming to WebRTC soon, one day. The last area I'd like to discuss is real-time communications optimization. There are many opportunities to use machine learning to improve bandwidth estimation and help with things like echo cancellation. And you can imagine with error correction, you're missing packets. Machine learning can oftentimes fill in gaps and details and perhaps can reproduce the image for you, right? So you can actually potentially have very good error correction. And even beyond that, just within the network and routing paths and trying to minimize latency, there's a lot of room for using machine learning instead of traditional heuristic methods to improve and provide better quality in a much more dynamic basis. Unfortunately, there's not too much actual real implementation of this stuff yet, but there are some very interesting experiments, I'd say. So one example here, this is a project that Mozilla did called RN Noise a little while ago. This is actually, they are using deep learning to provide better real-time noise suppression. And they designed this to work with low-power devices so that specialized hardware wasn't needed. Looks like I'm running a little bit over time where I was supposed to be, but I definitely encourage you to go and check out the link here. There's a good demo that lets you even record your own voice and see how machine learning-based noise suppression can be an improvement over a lot of the techniques that are out there today. Unfortunately, like I said, this was just a research project. Again, I was very surprised that there's not more work being done to use machine learning as part of the core, real-time communications codex out there. I hope that will come, but there's actually relatively very little work being done on that versus some of the other areas. So we'll need to see. Maybe before I take a minute to take any questions, I did just want to say if anyone is interested in more research in this area, there's a discount code there, or you just email me and ask about it. With that, if there's any questions or comments, I'd be happy to discuss now. Contact information, feel free to contact me offline.